Yes, sir. Good morning, all. So, guys, in today's class, we'll see the concept of database. Okay. So, first, let me explain why we are learning the database concept here. In the previous classes, we have seen the concept of HTML, CSS, and then we have seen the concept of JavaScript, and then we have seen a framework like jQuery and Bootstrap. In addition to all this, we have seen Git and GitHub. Okay, see guys, Git and GitHub are meant for the purpose of sharing the code. Sharing the code, we'll use Git and GitHub, and also which is meant for to collaboratively work with the colleagues. We can go with this Git and GitHub concept. Okay, this is somewhat apart from all the things what we are learning right now. Yes, we have seen the HTML, CSS, jQuery, and Bootstrap. Among these two are a kind of frameworks, and these three are languages. Okay, at the end, finally, with the help of all these concepts, we can able to simply define a front end website. Okay, I mean, if any client asks you to develop a web page like I need to have some kind of navigation bar, I need to have some kind of sign up form, I need to have some kind of login form, I need to submit the data to the server, or some kind of footer, some kind of slider, like that. If any client asks for you, you need to develop a website. That front end part you can simply design with the help of these languages what you have seen up to now, meaning that whatever thing that we have learned so far, with the help of that we can able to develop user interface part. Okay, fine. So up to now we can able to simply develop any kind of user interface. Now I am going for discussing the concept of database. Why we are discussing here is, let us take, there is a kind of a form. You have implemented a form where this form is responsible for to store the user data. To store the data, like let us assume that sign up form. Sign up form. Now what you have to do, user will enter some data that you can implement easily, and when the user clicks on submit button, that data need to be stored in the database in the form of a table. Basically, we are going to store in the form of table, right? If the user entered data to store in the database, we need to send this data from here to this particular location. This particular location. How we are going to send means, this is a separate part. Front end it is a separate part, and database is a separate part. How we are going to send? It is not possible. We have a mediator required. That mediator required, we can call it as backend language. Backend language. That backend language can be a PHP, or it can be a kind of a Java, or it can be a kind of a .NET, any kind of language, backend language. With the help of this backend language, I can able to take the user entered data and I can store in the database simply. This is what I call it as a database. Yes. So in this session, before going for any kind of backend language like PHP, I am first concentrating on database, because once you know the concept of database, then you can able to simply work with backend language, where this backend language will contain the user interface part along with the database part. So we already know the user interface part. Once you know the database part, then you can able to go for combining these two in the backend language. That's why first I am moving for database part. Okay, let me move for the concept of database. Guys, here there is a keyword here you can observe, that is data. What do you mean by data first? Meaning that it can be any kind of raw fact raw fact that we can collect from the real world. We can call it as a data. Okay, for example guys, the administration of RGUKT is saying all the CSC students all the CSC students are taking breakfast on Monday. Breakfast on Monday. This is a kind of generalized term. This is a kind of generalized term, right? All the students means the data which we are having available with the administration simply. That is what we call it as raw fact. All the students I am calling it as a data. Okay. When we process this one, when we process the data, that is what we call it as information. We call it as information. I mean, how we are going to process, for example, if somebody asks, how many students have taken breakfast on Monday? Breakfast on Monday. Then what we need to do? They have to process the existing data by collecting from the mess. By collecting from the mess. And then we can able to get some kind of data. That data we call it as an information, which is having some meaning. In simple terminology, we can say that it's having meaning. In database, what kind of thing exists? In database, we can have a meaningful data or can be a non-meaningful data. If you want to convert a non-meaningful data into meaningful data, we need to process it. That's it. Okay, fine. So once we know these two terminology, then we can go for the main term, database. Database. See, database can contain a meaningful data or it can be a non-meaningful data. Simply we can say that a collection of interrelated data, we call it as a database. Or we can say that we are trying to store data in the form of some structure, right? So that is what I'm saying. A database can be a collection of data that can be in some structured format. That structure format can be something like in the form of tables, as you know that already, in the form of tables, or it can store in the form of objects, or it can be in any other format. That's what so we call it as a database. Okay, fine. So guys, you know there are various kind of database are there. Among those, one kind of database is relational database. Relational database. Okay, in relational database, the data are going to store in the form of tables. In the form of tables. Some other database like there something like historical databases are there, where some old data they are going to maintain. They are going to maintain some old data. That is what we call as historical databases, or something like current databases, something like latest data if they are maintaining, that is what we call it as current database. Something like old data means if it is more than 3 years, if it stores more than 3 years data, then it's called as historical. If it stores less than 3 years, we can call it as a current databases. Or something like graphical databases, meaning that this is a kind of database which will store only the image data. We can call it as graphical databases. Or something like geographical databases, where this kind of database stores the data like maps, etc. Like this, we'll have various kind of databases based upon the way the data storing, based upon the way data storing, based upon the way data storing, they have classified into different kind of databases. Among those, you have know already a kind of database that is relational database. Relational database. I mean, guys, what I am trying to conclude here is, if I am having some kind of database, this is a database. This database can have a data of type some structured or it can be any kind of unstructured, or it can be any kind of database. Yes, this is a kind of a physical component. This is a kind of physical component, right? Yes. Now, if any user would like to communicate with this physical component, can they directly interact with this database? No. They have to involve some kind of software. They have to involve some kind of software. That software, we will call it as DBMS. Database Management System is a kind of software which is meant for to perform various kind of operations on the database. In order to perform various kind of operations on the database, we need to have a certain software. That software will be available in various languages. In various languages, that can be any kind of SQL language, or it can be any kind of PL by SQL language, or it can be any kind of UNQL language, or it can be any kind of NoSQL language, etc. So like this, we'll have various kind of languages are there. So various kind of software is there. So there is a software. This software, you are going to work with a language. See, Java is a kind of language, right? Similarly, if you like to work with database, we have various kind of languages are there. These languages will be used depending upon the type of database. Okay, if it is a database which is related to something like a relational databases, then we can go with basically SQL, PL by SQL, etc. If your database are something like non-relational databases, we'll go with UNQL, NoSQL, etc. Okay, SQL means it's a kind of a structured query language. I will go with only basic definition. It's a kind of a structured query language, and it is a non-procedure language. Non-procedure language. I mean, so why I am saying that here it is a non-procedure means, whereas coming to PL by SQL, PL by SQL is a kind of procedural language extended to structured query language. Extended to structured query language. I mean, guys, there is a little bit difference between these two. Both are working with relational database only, but the thing is, whenever you are going to write a query, you are going to simply define define what to get. You're going to simply define what to get, and you are not defining how to get it. You are not defining how to get it. Internally, the SQL compiler will convert it into a kind of procedure, and it will provide a result for you. Whereas coming to PL by SQL, it's a kind of a procedure language where you need to define what to get, and you need to define how to get also. That is the difference between SQL and PL by SQL. Okay, these are some kind of languages. That's it. Some kind of software tools. Yes, guys. So if you go for UNQL, it's a kind of unstructured query language. Unstructured query language, meaning that the data is not available in the form of relation. Then we can go for uncle language like NoSQL. NoSQL. Something like non-relation databases like you can observe some databases nowadays were very famous. Mongo database. Mongo database is a kind of non-relational database which will store the data in the form of objects. That is what we call it as uh, uncle language. That is NoSQL. Okay, fine. So we'll see this one at the later part of our class. Okay, fine, guys. So what I'm trying to convey to here is there are various kind of DBMS languages are there. DBMS languages are there. That DBMS language can be SQL, PL by SQL, or it can be uncle, etc. etc. Right? If you are trying to work with a kind of database, if you are trying to work with a kind of database like relational database, then the DBMS language, we can call it as relational database management software. Relational database management software, right? For this relational database management software, what language you are going to use? You are going to use either SQL or PL by SQL. Here we can able to work with SQL. Guys, there is a little bit difference between, once again, not only about this, we'll have some more differences there in SQL and PL SQL. PL SQL will support some kind of if conditions, some kind of loops, some kind of triggers, etc. There are a lot of differences are there. Among those, I have defined some differences like if loops, triggers. All these are going to be supported by PL SQL, whereas SQL won't support all these things. Okay, fine. So here we'll use SQL language in order to work with my relational database management system, where I can able to perform various kind of operations. Okay, guys, in this SQL, when you are trying to work with in your system in real time, what you are trying to work with a kind of database like MySQL, or trying to work with Oracle, or trying to work with some kind of SQL server, MariaDB, or something like DB2, etc. Like this, will have various kind of databases are there you are trying to work with here. Okay, fine. So let me explain what is this. See, SQL is a kind of a concept. That concept you are going to implement with the help of MySQL. MySQL. Okay. See, when you are trying to work with different kind of database, like these are all will comes under relational databases. Relational databases. So when you are trying to work with these relational databases, we have to know a common language like SQL. SQL is a kind of a common interface language, for all languages. But there is a slightly difference between one language to one language. But the main operations like create, update, delete, all will be the same, but the remaining features may be somewhat different. For example, guys, let me take something like, I am asking for you to write a program related to palindrome. Program related to palindrome. You can write logic, right? You can write logic. Yes. This logic you can able to implement in C language, you can able to implement in Java language, you can able to implement in Python, or you can able to implement in .NET, etc. Am I right or not? In this particular session, SQL is palindrome logic, whereas that implementation I am going to do in my C language or Java or Python. What about the difference? There will be slight difference between the structure. That's it. Internal entire logic is same, only the structure is varying. So that is way. So if you know the language of SQL, you can obviously can implement with help of any one of the implemented language like MySQL, Oracle, all these things. Okay, fine. Or else, for example, let me take some kind of car driving command. Car driving, guys, once you know car driving, that car driving you can able to implement it in any kind of car. Like you can work with, you can drive in the BMW car, or you can drive in some kind of Toyota, or some kind of Jeep, or whatever it may be, Ambassador, etc. Right? So here car driving is a kind of a concept, that is language. This language I can able to implement it on BMW or Toyota or Jeep, like that. So this is the clear difference between SQL, MySQL, Oracle. So SQL is a kind of a common interface language. That language I am going to implement via MySQL database, Oracle database, or something like this. But there is a slight difference between the queries also. Something like if you take Oracle, in Oracle there is a data type called varchar2, but there is no data type called varchar in MySQL. Okay, fine. This is the simple hierarchy of SQL. So in our academics, what we are trying to do is we are trying to work with MySQL database. What do you mean by MySQL database? MySQL is a kind of a relational database where data will be stored in the form of relations. So that's why I would like to go with MySQL. MySQL. MySQL is a kind of a database where the data will be stored in the form of tables or it will be stored in the form of relations. Tables means something, it's a kind of a collection of rows and columns. Collection of rows and columns where each row where each row I can generally call it as a row or technically I can call it as a tuple. Technically I call it as a tuple. Each column I can call it as attribute or I can call it as non-technically that is column. That is column. If you take the entire structure, if you take this entire structure, guys, you know this already, but for your understanding, I am revising everything. If you take this structure, that is what we call it as schema. We call it as schema. Okay, fine. So this is the basic terminology about the table. Guys, if you take any kind of language like SQL, if you take any kind of language like SQL, that SQL language will support various kind of languages, various kind of sub languages. Like that can be a DDL language, that can be a DML language, DQL language, DCL, and TCL. So I think I have given already PDF for you. In this PDF, everything is there. DDL means data definition language, where you are going to perform create operation. We can able to perform alter operation. We can able to perform drop. We're coming to data manipulation language. We are trying to manipulate the data. That is insertion operation, updation operation, or you can perform some kind of delete operation. Data query language means we are trying to perform querying on database. That querying you can able to do with the help of select query. Data control language, which is meant for to control the data. That means when somebody is trying to take the data, we need to control it. That controlling we can able to do with help of by granting some permissions, whether they would like to take it or not. Like that we are trying to grant it. Once you have granted the permissions, if you would like to get back those permissions, we can go for using a command called revoke command. Revoke command. Coming to transactional control language, like that can be commit operation commit operation, or it can be rollback operation. Commit means I need to permanently saved it. I need to permanently saved it. Rollback means once you saved that, if you want to get back to the previous state, I can go with rollback. I can go with rollback. So SQL is a kind of a concept. Is a kind of a concept. I mean, it's a kind of a general language. This general language will be implemented with MySQL, Oracle, SQL Server, MariaDB, DB2, like that. Like that. Now in our syllabus, we are trying to work with MySQL. So in MySQL also, you will get all these languages like DDL, DML, DQL, DCL, TCL. So through MySQL, we are trying to implement that. We are trying to implement, yes. Okay, so once we know the structure, right? So for example, let me take this is a kind of a table. Here we'll have serial number, we'll have a name, we'll have marks, we'll have some kind of age, some kind of date, right? Guys, schema represents it's a kind of a structure, right? So if you would like to define the structure, if you'd like to define a table structure, then you have to know some kind of basic concepts like data types. Data types you have to know. So while writing the queries, you have to compulsory know these data types, right? So the data types means we are simply defining to the database that what type of data we are trying to store in the columns. Something like I can able to store a kind of numerical data, or we can store a kind of a character data, or we can store a kind of boolean data, something like blob or club or something like data types, etc. Various kind of data types are there. All these data types we are trying to work. For example, if you would like to work with any kind of integer data, if you would like to define a column as integer column, then I can go with int, or I can go with integer. No need to define the size. Size will automatically taken by this database compile. Integer, or you can go with teeny int. So you can go with all these. You know, I don't need to explain here in like that. So coming to characters, you can go with defining that size of the string. For example, let me take 4. The string is having a maximum of 4 characters. Or you can go with, if it is MySQL, I can go with varchar of something. If it is Oracle, I need to go with varchar 2 of 40. So there is a slight difference, right? I said already. So varchar of 40 means it is going to accept a variable length of 40 size. So there is a difference between varchar and varchar2 also that you can go through. Boolean means it can be a true or it can be a false. False means it should be a 0. If the value is more than 0, then I can call it as a true. Blob means a binary object. Clob means character object. So binary object means all the images are stored in the form of image, binary format, right? That is images. Character data, if you would like to work with, then you can go with the clob. And coming to dates, if you would like to store the date in your database, then I can go with the date data type, etc. Like this, we'll have various kind of data types are there. And then we need to know the concept of various kind of keys, right? Yes, the keys can be some kind of primary key. Primary key, guys. Primary key is a kind of a column, or it's a kind of a some key which is meant for to identify entire table uniquely. I can go with a key. That key can be a primary key. This should be not null. This should be not null, and it should be a unique column, meaning that it should not allow null values, and it should be unique. Duplicate should not be allowed. That is the meaning of primary key. That's the meaning of primary key. If you go for candidate key, candidate key. So in a table, there may be more number of columns. There may be more than one column, or we can call it as simply there will be more than one key, more than one key, which is able to identify our table uniquely. Then each key I can call it as a candidate key. Each key I can call it as a candidate key. Okay, fine. See guys, for example, serial number itself is identifying the entire table uniquely, then I can call it as a candidate key. Whereas name itself is identifying uniquely, then I can call it as also a candidate key. Meaning that there are two candidate keys are there here. Out of those, one key I will consider as a primary key. In a table, only one primary key will exist. Only one primary key exists. But candidate keys can be more than one. More than one. Next kind of key is super key. Super key. Union of columns with candidate key, we can call it as super key. Super key, I mean, for example, if we take serial number comma marks, which will also identify the table uniquely. Serial number comma marks, which will, sorry, serial number comma age, which will also identify the table uniquely. Or serial number comma marks comma age, which will also identify the uniquely. Like this all we call it as a super keys. Super keys. So super key means it's a kind of a key that will internally contains already a kind of key which will identify the table uniquely. So what the difference means? So the smallest key out of the candidate keys we call it as primary key. Primary key. Okay, fine. So like this we'll have various kind of keys. Is there any other thing is there? Like for example, let me take composite key, guys, which is important. It's important. Sometimes what will happen is in a table there wouldn't be any column which will uniquely identify your table. At that time, more than one column, more than one column can combine, can combine, and that particular combination of columns will able to identify your table uniquely. Then we can call it as a composite key. For example, serial number is unable to identify your table uniquely. And if you combine that serial number with name, serial number with name, if it is going to identify the table uniquely, then I can call it as a composite key. Call it as a composite key. Then there will be a kind of key called foreign key, which will apply based upon our referential integrity constraints, right? Yes, foreign key means, for example, there will be a table. There will be a table. Here, this is related. This data is related to the students. For example, this is serial number, faculty name, faculty subject number. Serial number 1, WT, faculty name is J. Krishna. Serial number 2, C language, faculty name is some K. Some K, right? So there are some sections. Let me take sections here. Sections here, right? So for example, section CSC1, CSC2, CSC3. I am trying to define the serial number as 1 and serial number as 2, serial number as 1. So here what I am trying to convey is, so serial number 1 faculty will go to section 1 and section 3. If you like define, meaning that, so this is a kind of a primary key, this is a foreign key. Why I am saying that this is a foreign key means, a column, if it is able to connect to primary key of other column, then I can call it as foreign key. This foreign key can be null, can be null, can allow duplicates also. Duplicates. That is what we call it as foreign key. Foreign key. See guys, if there is no primary key, if there is no number 1, then there is no WT for section CSC1 and CSC3. CSC1, CSC. That is the meaning of foreign key. See, if I am trying to write like something here 5, that will provide an error because there is no existence of primary key 5. That's why it won't allow to add the 5 here. So like this, we'll have various kind of keys concept is there. So this also you have to remember while working with database. And then we'll have various kind of constraints, unique constraints, not null constraints, all those things you remember, right? Not null constraint is there, unique constraint is there, referential integrity constraints are there, all those you can able to remember. So once we know all these things, we can able to work with MySQL database. MySQL database, right? So why I'm trying to work with MySQL database? It is a kind of relational database which we can able to store the data in the form of tables. Tables. Okay. With this concept, we can go for further. So next, what we can do is we can simply go for download the MySQL. Download the MySQL from the corresponding official website, or you can simply install exam server, which will internally contains MySQL database. We can able to work with anything, but in the class we'll go with MySQL what you have downloaded. That we can either go with MySQL client, or we can go with Workbench based upon our interest, and we'll go with the MySQL database of XAMPP while working with concept of PHP. Okay, fine. So for the coming class, what you can do is you can just install this software so that we'll move for further concept.